Welcome to a tutorial on how to create connector plates for custom railing templates using SolidSteel parametric. This video builds on the video on how to create your own railing templates. So if you haven't seen that video, be sure to watch it first. Just click on the info card at the top right to access the video. Okay, here is our starting point, which is the side-mounted railing in the status quo from the end of the video just mentioned, meaning a fully functional railing template that automatically adapts to the installation situation and offers variables for the number of posts, the filler rods, the overhangs of the handrail, and the lateral spacing. So far so good. What is still missing here are the mounting plates to bolt the railing to the stair stringer, and we are now adding these. To do this, we will first extend the railing sketch and then the parameters to add more controllable features to the railing dialog. The existing sketch does not need to be expanded much. We will start on the XY plane with a horizontal line. I dimension it to 100 mm, which is the approximate width for such a plate, and use a constraint to place the line with its center point here at the center of the existing profile. We are done with the assembly sketch and switch to the Assemble tab to start the parameters. Here, at the top of the model parameters, we see our new line with the name D37. We click Add Numeric to add a new user parameter for the length. The name starts with SSP so that this parameter will be present in the later railing dialog and can be changed there. The value of 100 mm that I enter here below is the default value that will be shown later in the dialog. Now we link our model parameter D37 to the user parameter we just defined. By the way, it's best to copy and paste the names here, and not to do it like I do. But my mistake is not bad for the video. As you can see, parameters are written in red and are not accepted if they are not exactly the same as in the user parameters. I'll fix that quickly. There was an extra S in the name below. The equation above is then simply the name of the user parameter. Alright, now we can confirm with done. We switch to the SolidSteel tab to place a profile on the line using the Create Beam feature. The 80 by 10 mm flat steel preset from the last use is a good fit. We just need to select the line. We see in the preview that the rotation is not correct, so we enter 90 degrees here at the bottom of the dialog to fix it. The rotation is now correct. However, we need to use a parallel offset to ensure that the face that will later join the stair is exactly at the end of the sketch line that defines the distance. We set the height offset to top and can confirm this with Execute. We now shorten the second profile with a face cut to remove the overlap of the profiles. Well, that looks good, but we still need a detail for the later boreholes. To do this, we are going to edit the profile we just added at part level. First, we insert an auxiliary line. Center it vertically on the profile and add 2 sketch points. We dimension the distance between the left point and the center at 30 mm and the distance between the points at 60 mm to achieve a symmetrical arrangement and finish the sketch. These 2 points will allow us to place the bolting precisely later. In the Manage tab we can find the parameters at the part level. We simply define the distance to the center and the distance between the points geometrically depending on the profile size. So D6 is calculated as a third of the profile length as the distance to the center, and D7 as the distance between the points, then simply equals D6 multiplied with 2. That's it, we can confirm. In the sketch, we can see from the FX in front of the dimensions that the values are now based on equations. We click Return to get back to the railing assembly. Okay, we're done drawing and setting parameters. Now it's time to create the pattern. Here is a reminder to watch the previous video. It describes the next step in detail. We'll do it relatively quickly in this video to keep it short. We select both the connection to the post and the connection plate, and then define the direction in which the pattern will be applied. The normal of this face of the handrail will point in exactly the right direction regardless of the angle at which the railing is mounted. The number of pattern components corresponds to the connection pattern parameter, and the distance corresponds to the length dist parameter, both of which were defined in the previous video. We confirm and can now see the components on all 4 posts. I'm going to hide the center point because otherwise it would be visible later when the railing is inserted, but that's just for the look. Saving the assembly can't hurt. Okay, let's switch to the SolidSteel tab and launch the Learn Railing feature. First, we give the new railing a name and define a preview image via the image path. I have already saved a screenshot of the railing as a JPEG, which I will use here. Below that are all the parameters that start with SSP and can therefore be displayed in the later railing dialog. For the first two parameters, I disable the input of values, but leave the check next to visible so that the calculated values are displayed in gray. The rest of the parameters remain enabled as they are to control the railing. A click on Execute saves the new railing template in the database. From now on, the railing can be used in SolidSteel parametric at any time and automatically adapts to the installation situation. Let's try it out right away. Here we have a demo assembly with a horizontal and an angled beam. We start the railing feature and first select a side face, and then the railing template we have just created. We see the schematic preview and the more detailed preview image in the dialog. In the dialog, we can now change the parameters as needed, such as a start offset and an end offset. We can reduce the side distance to 130 mm so that there is not a large gap between the railing and the beam. And then confirm to insert the railing. There it is. It looks good, and as you can see, the side offset was large enough. We add another railing directly to the inclined beam. The steps are identical, so we select a side face. SolidSteel parametric has remembered the last used template as well as the start and end offset, so we immediately get the schematic preview. I set the side distance to 130 mm again, reduce the number of intermediate posts and horizontal rods to 1 each, and also add this railing by clicking on Execute. Okay, both railings are in place. You can clearly see the effect of the changed parameters and adjustments on the angle of the railing. Now let's move on to the bolting. The sketch points we just added will be very useful for this task. We start the manual bolting feature and use the selection mode for sketch points. There is also a separate video on manual bolting, which I will link to in the video description. Now we define the side of our connecting plate as the start face and the opposite face of the web as the end face. This selection defines the grip length of the later bolting. As a third selection, the dialog expects at least one sketch point for the exact positioning of the bolting. We perform a multiple selection with all 8 sketch points at once. No additional keystrokes are required, just select one after the other. If an incorrect sketch point is selected by mistake, it can be deselected with Shift plus click. A click on Add Selection adds all selected sketch points, and a click on Assemble opens the part selection to define the bolted joint in detail. We define the screw via standard and diameter. 12 mm should be sufficient. A click on Add adds the screw, and a click on Default Mountings adds 2 washers and a nut that match the standard. We confirm, and the preview of the bolted joints appears in our railing assembly. Looks good. Confirming by clicking the plus button of the manual bolting dialog adds all 8 bolted connections at once and leaves the dialog open. We will use the dialog again directly for the second railing. We select the start and end faces for the bolted connection, and then the sketch points, which I have sped up for the video. We don't have to define the bolts again. SolidSteel has remembered the last used settings. We can confirm directly, this time with Execute, so the dialog we don't need again is closed. With this, we have not only extended the railing template with connection plates, but also placed 2 railings including complete bolted connections. Of course, the required holes for the bolting are also inserted in the plates as well as in the profiles. If you want to know more about how SolidSteel parametric can save you a lot of time in steel design, take a look at the video about custom and AI connections suggested here. Thanks for watching and see you next time.